Good afternoon, everyone. This is Elisa Baum. I am GridGain's Director of Product Marketing. We will begin in just a moment, but first I'd like to conduct just a bit of housekeeping. Could you please raise your hand using the hand icon in the GoToWebinar control panel to let me know if you can hear me? So please go ahead and click on that. Okay, great. I see everybody can hear me. Next, during this webinar, you will be on mute, but should you have any questions during the discussion, please go ahead and enter them in the field within the control panel. At the end of the webinar, we'll take time to answer as many questions as possible, and those that aren't addressed will be answered in a follow-up blog entry on GridGain's blog. In addition, I'll make sure that every one of you has a recording of this webinar and links to the slide within 48 hours. I would like to thank you for attending today's webinar. It's called In-Memory Computing for High-Performance Financial Applications, being presented by GridGain's Eric Karpman. He is our Director of Business Development for the financial services industry and a 30-year veteran of the financial services industry. With that said, I will turn the floor over to Eric. Go ahead, Eric.
Thank you, Lisa. Hello, everybody. Welcome to our first webinar in this series. I plan to conduct those periodically, specifically with specific emphasis on financial services. So why financial services? Obviously, we are seeing big growth in memory computing, in improvements in speed, performance, reduction of latency, and a few other things that make financial services quite unique in other industries and making them perfect candidates to adopt our technology. So again, I've spent almost 30 years, more than about 25 years or so, specifically in financial services industry, and worked at different investment banks as well as large asset management firms as well as exchanges. Quite familiar with issues related to those financial institutions and how they struggle with some of the issues that are happening today with increased regulations, with real-time analytics, with high-frequency trading, algorithmic trading, backtesting, and a few other things that we'll talk about during today's webinar, and how GridGain's technology can help in this. So let me start off with a brief introduction about in-memory grid computing and why right now it's such a big deal, and a lot of companies are adopting this. Well, first of all, we are seeing that there is a need for performance improvements in various applications in which we operate. Databases, trading applications, market data processing, various events processing within financial services applications, risk management, and so on. Everywhere we see a need for improvements in performance. We're seeing that legacy systems don't perform as well, and when we are looking at rebuilding those with newer platforms, newer applications, we see that, well, the paradigm changed. There's much more data exists today and needs to be processed from multiple sources than ever before. And again, traditional storage-based systems just cannot perform up to the level needed. Of course, there are some other ways to improve performance, flash storage, SSD, memory channel storage, and so on. But those usually give us maybe 2 to 3 times performance improvements that, versus traditional storage, which may be good for certain applications, but certainly not good for applications that saw growth in data and in increased numbers of transactions in the order of magnitude of 100 times and more. That's where a move towards memory is really required, where we can see that we are now doing hundreds times faster processing of data, while cost is still within the similar levels of flash, maybe slightly higher than flash, but not necessarily, not up to the level of of real expensive RAM and memory that used to cost us before. Right now, it's the cost of memory is getting closer to the cost of disk, and that's why it's a real, attractive case for many institutions to switch to this technology. Plus, big data is a big phenomenon today that most of the larger financial companies at least are moving into big data processing, creating ways of accessing data from multiple sources simultaneously. Again, that adds a significant load onto existing systems, and we believe that our in-memory grid computing system can solve that problem quite effectively. We are also utilizing clusters and grids in our technology, meaning that the system can be very scalable. You can decide how many servers, how many cores you need to store the data that you're working with right now and do the compute on this data. If you feel that your data is really growing further and further, you can just increase the number of those cores, increase the number of servers, and this way you scale up to the level that you need to go. Now we can move into specific financial customer use cases that we're seeing. And as you can see also on the slide, there's a lot of financial institutions that had already become our clients. We are talking to dozens of new companies of a similar scale that are considering us and doing proof of concepts with us in most of the cases that I am describing here. So let's concentrate on why they're looking into our technology and what type of issues they're experiencing right now. Well, obviously, trading platforms is a big area where our technology could be used. There are many systems within different banks that process orders, process executions, process bids and quotes at the same time. There are lots of advanced trading strategies that the banks utilize. Many more transactions now than before because of algorithmic trading. The average size of the trade was about 7 times larger 5 years ago, 6 years ago than it is today, due to those various algorithmic trading strategies that split the order into smaller pieces that need to be executed and then put back together. Everything needs to be done in low latencies because, again, that's really the competitive advantage of the firm. And obviously, one way of reducing that latency, improving performance, is using the in-memory computing technologies. Risk management is a huge area where our technology is used today. It's, right now everybody's talking about real-time risk analytics, so that any event, any change in a price, any change with interest rate, any change with currency fluctuation definitely results in repricing, re-reviewing the risk management profile of different positions within the firm to correctly identify current exposure. Again, what that means is that with every tick, with every change in the market, you need to reevaluate, reprice, recalculate your positions, your P&L, your risk profiles, risk scoring. Traditional databases, traditional storage-based systems cannot handle this. So I remember when I was working for larger banks, we did this first at the end of the day. So at the end of the day, when traders were closing their positions, when automatic recalculation would be kicked off, and it was taking hours and hours to do, so that in the morning when the traders and risk managers and compliance officers get back onto their desks, they can see those recalculated positions, that recalculated information so that they can start their day. Well, then, during financial crisis of 2008, 2009, I was also working for a large global institution, and that wasn't enough because the prices were changing so fast, information in the markets were changing so fast that again it wasn't enough to do the end of the day recalculations on the risk management side, and the bank required periodic reassessments, periodic recalculations throughout the day, which were again taking hours to recalculate, almost an hour to recalculate, sometimes more than an hour to recalculate. This is not really very effective risk management that's required today. So again, if you go to an in-memory computing platform, such as GridGain's platform or other vendors' platforms, you will see significant improvements in that, and you can calculate in milliseconds or seconds what you had done before in hours during traditional approaches with storage-based computing. I'll give you an example. We had a large European bank that was trying to do this risk management, real-time risk management analytics using in-memory computing. And the numbers that we achieved even surprised us. They've invested about $25,000 worth of hardware and were able to achieve 1 billion transactions per second, which was more than enough for them to recalculate all of their positions based on any movement in the market. This, before in-memory computing, even companies who spent millions of dollars on hardware could only achieve between maybe 5 to 10 million transactions per second in risk analytics that we're now calculating in billions. That's a significant improvement, and something to definitely look into if that's the area of your interest. Financial analytics is another big area where we see a use of our technology. Again, there's analytics on the execution side, there's analytics on the transactional cost side, on complex event processing side, sentiment analysis, and so on. So where basically you have different trading strategies that need to receive events, ticks, news, and notices from the market, and based on that needs to analyze how that type of event before, what was changing the market before, and based on what the market is right now, how this news, how this event is changing the sentiment of people, and what probably will happen as a result of this news or this event. So a lot of companies, a lot of our clients are actually investing into those technology, into those strategies, and therefore they need technology that can also provide that type of analysis on multiple data feeds, and based on any one change, any one tick coming in from the market, predict what should happen based on analysis of historical data, based on the current view of the market, predict what will happen with the price of a stock or a bond or any of the other financial instruments. Again, that requires significant amount of computing in relatively small period of time, because once if you're too late in doing those calculations, then the market already reacted, and then your conclusion will probably be wrong. So you need to evaluate all this information in real time, faster than others. And again, we believe that our in-memory computing system is probably a great candidate for this type of processing. We also are familiar with issues people have had in investment banks and asset management firms on options calculations and other derivatives pricing calculations, because you have to really analyze a lot of data. You need to solve very complex equations, Black-Scholes and others, in order to correctly price different derivative instruments. And again, it was a significant effort and computing power on the firms to do that type of calculation. Again, because of the nature of our platform, that it's fully in-memory capable, is able to process data and multiple nodes at the same time. This is, again, makes us great technology for that type of advanced pricing and options and derivatives calculations in financial analytics. I already mentioned big data analytics. I think it's really important that the firms now are moving towards multiple sources of data, really looking at data from different angles, being able to access data in real time, being able to create calculations based on the data residing in multiple silos and multiple data warehouses or in multiple databases, and make a decision of which data is the correct one, which is a complete or master copy, and which is an outdated copy. So all this information needs to, again, happen in real time, and we believe our platform with our Hadoop adapters, with our streaming adapters, is able to solve those issues quite nicely, and we are seeing this in examples of some of the clients that you see, whose logos that you see on this page. The next area is compliance and monitoring. That's definitely growing for us. Obviously, we are living in a world of high regulations, high compliance mandates right now, and what that means is that the data needs to be analyzed from multiple angles, right? You need to look at certain lists of individuals that maybe under sanctions, or companies or countries, or customers doing activities which are probably not in line with their normal activities. We need to see the industries that are being involved in different money transfers and other instances. Fraud, we need to analyze again whether where the information, where the requests or data is coming from, which country, which entity, the amounts, instructions coming with those messages, right? So a lot of information needs to be analyzed, needs to look back into understanding whether this fits into the normal profile of this client or not. Sometimes even checking social media, sometimes checking external databases with filing some different firms and what they do. So it's quite complex today, much more complex than it was before. And again, this type of compliance, this type of monitoring needs to be proactive, needs to happen in real time before the transaction is approved. And what does that mean? Well, if you are checking every transaction, every payment, every transfer for any kind of fraud, anti-money laundering, your customer rules, market manipulation rules, sanctioned lists, and so on and so forth, then it's probably going to take a while for that transaction to occur. Everybody today expects, if I'm making a transaction from one account to another, it should be pretty instantaneous that the money should show up in somebody else's account, or in my account for that matter. Or if I'm doing a, ATM withdrawal or a credit card payment, I expect that a transaction to proceed right away without being slowed down by all those bumps of checking for different compliance rules. Again, traditional technology that we see, database-driven technology, disk-based analytical systems, and so on, you just cannot handle this type of requirement right now, because we're talking about, again, hundreds of thousands of transactions per second, probably, if not millions of transactions per second. And They need to be approved quite quickly, and they need a number of different sources need to be checked at the same time. All of this is going to affect performance, and therefore will affect the timing that each transaction is going to take place, and the customer satisfaction and everything else related to this. So again, moving into a technology such as ours, I think is going to solve that problem, and we're already seeing it being solved at a couple of other larger banks that are sending all of their retail banking transactions through us and checking those sophisticated AML, KYC, anti-fraud rules on our system, and in real time and in millisecond, basically processing every transaction that occurs. On the investment banking side as well, within the investment bank side, we have also pre- and post-trade compliance models that again are being regulated heavily today. We need to check for any market manipulation, market abuse, trading before everybody else, trading during last minute of trading hours, first minutes of trading hours, trading right before the news occurs, right? So all of those models need to be checked and analyzed again before the trade is allowed to proceed, to avoid any conflicts, any sanctions, any fines and issues later on during various audits that we go through, right? So again, our system is quite capable of doing this. Final point here in this slide is this software as a service platforms. As you can see again from the logos on this page, a number of our clients are financial technology firms, right? Those are that process lots of transactions, lots of information for their end clients who are financial firms who go into those platforms, and especially software as a service platform. So if you go into your risk management or your market data analytics and other transaction cost analysis analytics and other analytics using your vendor's cloud model or software as a service model, then in some cases you'll probably hit our platform that will be used there, because our platform is fully multi-tenant. A lot of different requests are coming in at the same time on different instances of those platforms, and again, traditional storage-based systems cannot handle that flow. That's why those financial technology firms are choosing us, and there's actually a growing number of them, as I'm talking to quite a number of those firms right now, and they're all interested in our technology for their cloud offerings, software as a service offerings. So again, if you are working for such firm, you might want to consider this and contact me where we can talk more about this. Next is we have one of our largest clients today is Bearbank, is the largest bank in Russia and Eastern Europe, and the third largest in Europe, is basically moving a lot of their database processing, traditional database processing, traditional transactional processing that they've done within both retail and investment banking side onto GridGain's platform. And this was a very interesting project where it's a project that's going on, but how we got into this was basically Bearbank decided that, well, they are growing, or noticed that they're growing, several times, 100 to 200 to 300 times every year in terms of the number of transactions they were performing. And this was obviously happening for a number of reasons, similar to what the other banks are seeing today, that there is a less and less dependency on traditional branches and branch processing, and more into 24/7 online processing of transactions, ATM processing of transactions, mobile processing of transactions, and so on. So it's really the bank changed its face. It's really a different type of an institution than it used to be, and that creates a different paradigm, that we need to be able to almost offer similar 24/7 capability of processing dozens, if not hundreds of thousands of transactions per second, and being able to do this in real time, passing through all those rules and compliance checks that we talked about before. All of this needs to happen instantaneously. And Bearbank saw that, well, it wasn't really their traditional legacy Oracle-based platforms were not adequately servicing them. There were performance issues with this setup, and they started analyzing different in-memory computing vendors. And they've looked at more than 10 different vendors, I believe close to 15 different vendors, everybody from Oracle and SAP and Hazelcast and many other technologies they've looked into. And basically they ran tests. They set up a lab with a bunch of servers, and then they were setting up those different technologies and running transactions through those technologies and looking at the results. And basically after that test was complete, they contacted us and said that we were the best in performance category that they've evaluated. We also were the best in terms of fault tolerance and scalability. You know, in terms of our full SQL support, transactional consistency, all the database-like features that traditional features that they liked, they saw them in our platform, but they also saw performance and scalability that they couldn't really get with any of the other technology that they've evaluated. So they came back to us and they discussed about us replacing Oracle in certain cases and definitely becoming their platform of choice for transactions processing. And we're talking about huge, you know, they have 130 million customers. They have about 900 million accounts. That we're talking about, you know, hundreds of thousands of ATM machines. So it's a really massive setup for us. It's a massive bank that decided that this was a platform that they wanted to standardize on. And as you can see, basically, was the case where I told you before. When they tested us, they saw output of about 1 billion transactions per second, which they could not see anything close with any of our competitors. And they ran this test on the 10 Dell R610 blades with about 1 terabyte of memory. And this whole setup of about 10 of such blade servers cost them about $25,000, which is pretty good price tag for so many transactions. They were so happy that basically a CEO of the bank, Herman Gref, he spoke about this whole setup in the RBC article in January of this year, where he basically mentioned that with GridGain, specifically mentioning us, with GridGain, they're able to get to the level of performance and reliability and scalability that they couldn't ever get before, or couldn't also see anything like that from the competitors such as Oracle, IBM, and others that he can mention by names, us versus some of our bigger competitors, which was quite interesting and good for us. And we're happy that we've been valued so heavily. And certainly now that we're already live in certain parts of their bank and doing significant tests in other parts of the bank, we are also seeing that these results are there to stay. Those were not really exceptionally for their test environment. We are also seeing in live environments similar types of numbers. Again, we've been noticed by the analysts on the street. Gartner names GridGain a cool vendor for in-memory computing. There are also other companies that notice us. We constantly get calls even from IBM's, Microsoft's, and others about Oracle. About how maybe they can partner with us, what they can do with us, because obviously we've been noted in the industry by different players, mentioned by name by CEO of a large bank. So there's really a lot of hype now about us, and a lot of requests coming in from different banks, different institutions about looking at us, doing proof of concept with us, and working with us. So it's a lot of excitement going on right now, and I hope you can join us in this. Let's talk a little bit about what GridGain is and how we are open source based technology, but also adding some of the features which open source traditionally does not cover. GridGain Enterprise is based on Apache Ignite. The Apache Ignite was a product that basically GridGain founders had built and then released into Apache frameworks to make it a fully open source product. It's one of the top downloadable products within the Apache framework today. It's fully open source. It's not really controlled by any one company at this point. We have a number of contributors, committers into this framework. So we, it's all everybody can add on their own features if they feel like they will add value to Apache. So Apache Ignite. So all of this is happening. Enterprise Edition customers can benefit from the system being open source, again, because it's not controlled by one company, by one country. It's fully a community-based project. But obviously, open source also has its limitations. That normally the enterprise features that the large financial companies work with or require today, they're not there with the open source product. So that's where GridGain comes in, and it solves that problem. It solves those gaps. It bridges those gaps. That it creates exclusive enterprise class features that work on top of Apache Ignite. So you still have a core of the system which is fully based on Apache Ignite. So later on, if Ignite releases a new version, nothing is affected. You can easily upgrade to the new version. Your Apache Ignite is still going to be the core of your system, but you also have GridGain features for monitoring, for viewing, for additional security, for streaming, for some other things that we'll talk about shortly in the next slide. But just wanted to reemphasize that with this GridGain approach, you're actually doing, you're having both worlds in the same package. You have the full open source that is available to you from Apache Ignite, and the core is based on this open source Apache Ignite. But anything that's missing on the enterprise level side, that's going to be covered by GridGain. So with GridGain, you kind of fully covered if you're an enterprise client, enterprise customer. What is an in-memory data fabric? You've probably seen, I was addressing this many times. In-memory data fabric, not just in-memory database, but in-memory data fabric, because we believe that this is much more than a database. Obviously, there's a data grid where all of the data is distributed through the grid for high availability and and performance improvements. We also have compute grid, so the compute layer happens on top of the data layer. So again, to improve your performance, there's a service grid of actually monitoring any transactions that occur and changing things on the slide on the spot if you needed to make those changes. The streaming, Hadoop accelerations, clustering, full based file system, messaging and events. Events, as I mentioned, is something quite important in financial services, that we're able to capture multiple events at the same time, data structures, and so on. And all of this is being processed in near real time in practically the fastest available technology today in the market, for sure. A little bit more about this, what each of those layers means is that, well, I mentioned, data grid, so we have all this distributed caching and in-memory SQL, full SQL support on the data that's residing within our grid. With compute grid, we also can do risk analysis, machine learning, high-performance computing. All of that happens within the compute grid. That compute is working around the data grid on the same node. We also working with a service grid, and that's where high availability and monitoring comes into play, as well as the middleware components. Streaming with real-time analytics, big data, and again, some of the monitoring. Hadoop is we have separate adapters for big data that are able to take the data from wherever it resides within the big data environment. Advanced clustering, where we again provide even further fault tolerance, multiple backups, auto rebalancing, making the system as secure, if not more secure, than your traditional database-driven systems, disk-based systems. And file systems, it's a full in-memory distributed file system that we've introduced here. And messaging, advanced messaging, complex event processing, as I mentioned earlier, distributed queuing on the data structures, improvements in, again, how we process garbage collection, how we process memory, messaging and distributed objects being queried and processed at the same time. So all of that is also processed with our unique data structures, which have been created specifically for this project. We are also able to provide various adapters with the in-memory grid, in-memory data fabric here. Depending on the technology, on the language and technologies that you're using. If you're using Java, .NET, C++, SQL, all of those, Hadoop and MapReduce, all of those are supported with our APIs that you can use to program elements within the data grid. Also, if you intend to use additional databases, either structured or unstructured, outside of our platform, that's fine too. We provide an ability of connecting to those databases for additional elements to be accessed, for storage purposes. If we needed to store anything with from our grid onto this persisted layer. So if we wanted to persist any data elements, we can do that too. Our platform provides an ability of doing so. Main benefits, so just as we're getting about 15 minutes or so to the end of our discussion, so I wanted to talk a little bit about the benefits to summarize what we've talked about presenting this platform. So obviously, performance is our big differentiation here, as you heard me mentioning this with Bearbank and other banks that ran similar or their own unique proof of concepts and testing with us. They've all mentioned that performance is really unparalleled. There's nobody else with a similar performance, at least that what they could, the feedback that they could give us. It's really high throughput, it's low latency, it's full load balancing, it's caching and memory indexing, elimination of Java garbage collection poses and so on. So all of those additional more advanced algorithms we put together, all of this makes performance up to the level that you couldn't get to before. Scalability is obviously also one of our main differentiation points here, because we can easily add cluster members, more cores onto this, and without affecting the other members of the cluster, we can pretty much create unlimited vertical scaling. As so far we've gone through, thousands and thousands of cores, in certain cases for some of our banks, and it hasn't affected performance. And we believe that they can even grow further and further. Also, we can add memory if we wanted to, not to add additional cores, but to add memory into the existing cores, and obviously that's going to also increase available memory for us to work with. Definitely high availability, because yes, performance and scalability are really important, and that differentiates us. But we understand that large enterprises, especially financial institutions, require high availability. So we fully support any of the enterprise required features on the high availability side, such as data backups, such as data center replication, all the automatic failovers, high availability, persistence, fault tolerance, fast recovery, anything that you need to do, anything that's in your runbooks, anything that's in your data center required manuals, we will probably be able to support it, as we've kept adding more features to this to satisfy various requirements of large institutions, including very large financial institutions. We are quite unique on the transactional side, because yes, we are very fast, we are scalable, but we also understand requirements for financial transactions, right? We understand all the rollbacks, all the breakpoints. We understand the consistency of financial data, and all of that is built into our transactional support side. So all of that data, all of those requirements, all of that financial transactional requirement side from different regulators, as well as best practices within the financial industry, are fully supported within our transactional model. Persistence, as I mentioned earlier, if you decide to persist elsewhere outside of our grid, then that's fine. We are able to persist onto any SQL, NoSQL, Hadoop, into any kind of persisted storage, memory, databases, traditional and non-traditional elements of persistence. We're able to persist there if you need to. We also support two ways. We can persist on transactional side, we can persist on batch mode, so you'll decide at certain periods of time to persist. If you needed to, you don't have to persist with every transaction, or you can persist by placing transactions towards the end of the queue on the persistence side. So there are multiple algorithmic nuances of how persistence can be accommodated, and we are able to fully support that. On the security side, again, we are quite aware of importance of security with financial transactions and financial data, both on the store, on the store when you're storing data, as well as on when you're transmitting data. So our security model is fully compliant with the highest standards of financial transaction security requirements, with full authentication and authorizations, levels of encryption that are required to submit financial transactions, full tracing and full auditing on every transaction, on every access point that occurs within the system. So again, to summarize, basically what I'm describing here is we are fully, GridGain Enterprise is fully operational on top of Apache Ignite. And what that means is you can see here, basically with this table, what the Apache Ignite covers and what the GridGain's in-memory data fabric enterprise edition covers, right? So as I mentioned, everything that Apache Ignite covers is within GridGain, such as all the grids, streaming, clustering, all of that, the data structures, all of that is part of the GridGain because it's part of the Apache, and Apache, as I said, is a core of GridGain. But also, what's not there is covered by GridGain, such as I mentioned management and monitoring GUI, the enterprise level security, all the persistence that we provide to different sources of data, data center replication, integration with Oracle, Golden Gate, as well as our support models. We provide basic support or enterprise support, and our enterprise support is quite unparalleled. At 24/7, you will get a response. Somebody will start working on resolving this issue right away. So that type of support you can expect with the Enterprise Edition. And obviously, all the security updates, patches, releases, you'll get them firsthand, both from GridGain for the GridGain written components, as well as for anything on the Apache Ignite side, because as I mentioned, GridGain is the company behind Apache Ignite that built Apache Ignite. So obviously, you may want to receive your updates and patches even on the Apache Ignite core from the company that's fully committed, that's fully behind that road, basically, this product. My last slide here is on analyst validation. As I mentioned again earlier, we are receiving a lot of traction in the market, lots of interest from analysts, being contacted by a lot of them, and everybody who looks into our technology definitely notices a very rich set of functionality, enterprise required features, innovation on the technology side, and basically a leader in the segment of in-memory computing, in-memory grids, in-memory processing of data, especially for financial services firms. That basically concludes my part of the presentation, and if there are any questions, I'll be more than happy to answer them for the next 10 minutes that we've got. If not, then you can always contact me at GridGain, and I always like to hear about certain cases which are not resolved or there are issues with in traditional model and legacy models that companies currently run, and I'll be happy to provide you with case studies or similar information that I can share to you from our numerous installs within other financial institutions and how they've resolved the problems that you're currently having. Thank you so much. Alice, do we have any questions that came up?
Hi, Eric. There are no questions asked at the moment, but I did want to take a moment to just let everybody know that, again, I'll make sure that you get a copy of this webinar recording as well as the slides within 48 hours. I have to process the stuff after the event is over. Also, I wanted to invite you to to join Eric in the second webinar in his series for financial services. It's next week on July 20th, and it's called In-Memory Computing to Achieve Real-Time Financial Regulatory Compliance. So Eric will be joining us again next Wednesday. We hope that you can join us too. Eric, did you want to give any final thoughts before we wrap up today?
Yeah, absolutely. Thank you. So yes, this was really good that you mentioned next week's webinar. So I will try to concentrate. As I mentioned many different areas within financial services organizations today that are using GridGain or considering us for different use cases. And as I also mentioned, that we're seeing more and more requirements about financial regulations, compliance issues, some of those that I've kind of briefly mentioned during today's discussion. So that's going to be the core of our discussion next week, where we'll go through specific regulations and how GridGain can help to solve those, helps already to solve some of the firms, and I'll share some of my view of why it's really a requirement today to go with a faster analytics, faster systems to do more of proactive monitoring and analytics and responses to current financial regulations. Now, basically, I don't have anything else to add, but to say that if there are any questions that you did have today but just couldn't answer, I'll be happy to provide one-on-one discussion about that. I'm also meeting with a lot of banks throughout the world as I'm traveling extensively. So wherever you are, if you would like me to stop by and have a discussion, I'll be more than happy to do so. And if there's any feedback that you wanted to give me regarding the content of this webinar, or just to have a bilateral exchange of information, I'll be more than happy to also receive your comments at any point. Thank you so much.
Okay, Eric, thank you so much. And audience, thank you so much for joining us this afternoon. And we hope to see you next week. Everyone have a great evening or morning or afternoon, wherever you're calling in from. Thanks again, Eric.
Thank you.